Okay, so question 1. To integrate, we need to get it into the form where it's all powers of x, don't we? So first thing to do is, I'll keep that as 3x squared, but this needs to become a power of x. That's a negative a half, isn't it? Negative 2x to the negative a half. And then the one on the bottom, that just becomes negative. And then to integrate, we raise the power by 1 and then divide by the new power. We raise the power by 1 from negative a half to positive a half, and then that's going to be 2 divided by a half. And then we're going to have x to the negative 1 if we raise it up, so that'll be 7 divided by negative 1. So let's clean that up. 3 divided by 3 is 1, so it's giving us x cubed. Dividing by a half is the same as multiplying by 2, so that's minus 4 x to the half, and then dividing by negative gives us minus 7 x to the minus 1. Oh, and should have put in the plus c. Lose a mark if you don't do that. You can leave it like that, it's fine. If you've written it as 4 root x and minus 7 over x plus c, that's fine as well. Okay, so the factor theorem is saying that if we can find a value of x that makes that equal to 0, then you've found a factor. So if x minus 2 is a factor, what makes the bracket equal 0? So 2 would make the bracket equal 0, so we need to show that if we put our value of 2 in, we will get 0. So I'm just going to write this as 2 times 2 cubed minus 2 squared. Take 13 times 2 plus 14. And then we should really show a bit more of what we're doing. So 2 times 8 is 16. Take 4, take 26 plus 14. And then you just need to say, yeah, that does equal 0. Right, the hence or otherwise, well that means because we know x minus 2 goes into this, that's going to help us factorize this. We need to do a bit of long division on here. So we're dividing by x minus 2. We just divide the x into 2x cubed, which gives us 2x squared. 2x squared times x is 2x cubed. 2x squared times negative 2 is negative 4x squared. Now I take this from this, that goes. If I take negative 4, then that's adding 4, so that's going to give us 3x squared. Drop the negative 13x down. Divide x into 3x squared, we get plus 3x, times 3x by x, we get 3x squared. 3x times 2 is 6, so it's negative 6. If I take a negative, that's adding, so if I add 6 to negative 13, I get negative 7x. Drop the 14 down. X into negative 7x is just negative 7. Times those gives me that, times that by that gives me 14. If I take that from that, I obviously get 0. That means I know I've done it right because that is a factor of it, so I can now say that our function is equal to x minus 2 brackets 2x squared plus 3x take 7. Now they're going to want to see all the algebraic method, but you could probably get some way to solving this by putting it in your calculator, but the way I like to do this is to do 2 times 7 is 14. So because it's negative 14, we're actually looking for two numbers that multiply together to make 14, but whose difference is 3. So I've got 2 and 7. And I've just realised there isn't one. And then looking back here, read the question properly. 2 decimals places where appropriate. So you can, this is where we need to think about using the quadratic formula, isn't it? So a equals 2, b equals 3, c equals negative 7. And we can say that x is going to equal negative b plus or minus the root of b squared, so that is 3 squared, take 4 times 2 times c is negative 7, all over 2 times 2, which is 4. And sort that out should give us that, and they want it to 2 decimal places, so S to D, that gives me 1.27 to 2 decimal places. Just back up there and turn the plus to a negative, and that's going to give us negative 2.77. So we've got 3 answers for our solution. We've got x equals 2, because remember we got that from here, 1.27 or negative 2.77. Now it might not be that many marks, but I think vectors are so much simpler than most of the maths you've got to do here that it's worth taking time on them to make sure you get it right. And you can just remember the fact that to get from A to B, the vector from A to B, you take your A from your B. But to be honest, I'd always rather sketch it, because then you know what's going on and it makes this one easier anyway. So we've got negative 5i and we've got negative 8i over there. So it's generally all happening over here, isn't it? 1, 2, 3, 4, 5, 6, 7, 8. Negative 8 there, negative 5 there, and we've got 2 on the J, and we're going to have to go a bit higher here, 3, 4, 5, 6, 7, 8. So we've got position vector for A, negative 5 and plus, oh, why did I say 8? Plus 7, so that's over here. So I'm going to actually write that as if it's a coordinate like that, and there's me A. And then B is negative 8 on the I and 2j, so I'm going to actually write that in as well, just to make sure I don't get this. So what I need is, what do I go from A to B? So I'm going from A in that direction there, I'm going 3 in that direction, aren't I? So that's going minus 3i, and then I'm going down from 7 to 2. Well, that's 5, isn't it? So that is down 5 on the j. So vector AB is negative 3i take 5j. And then AB, the magnitude of AB, is the actual distance of the straight line from A to B. And that we can do using Pythagoras, because that's 3 long and that's 5 long. 3 squared plus 5 squared, well, that is 9 plus 25, isn't it? So AB is going to be the square root of 34, and that's in its simplest form. So that's how you can leave it as that. Right, so this before I even look at, I'm going to start by sketching the triangle so that you've got some idea of what's going on. So it says it's a 120-degree angle, so let's draw a nice obtuse angle in there, put in 120. The B is at the center, so then we'll have A up here, that's 2 minus x for AB, it's the other part of the triangle, and B to C is x plus 1. So this is looking like cosine rule. For one thing, it's got the squared going in, but also you've got sides either side of the named angle. So the cosine rule, since we've got it with the B, we're looking for AC squared there. Well, if we call that little b across there, we would have b squared equals a squared plus c squared minus 2, multiply those other two together, and then we would have cos b there. You would have learnt it with the letters in slightly different orders, but I just go with what I've got and think about it that way. So now we just need to substitute into that what we've got here. So AC squared, well, we may as well call that AC because that's what they've called it. AC squared is going to be equal to, both these lengths need to be squared, don't they? So which one do we call that? This one here. So x plus 1 squared plus 2 take x squared take 2 times, yeah, they both, oh, it's not B, is it? That should be A. X plus 1 times 2 minus x cos 120. Now, you should know it, but don't worry if you don't. Cos 120, if you pop that into your calculator, cos 120 is minus a half. So we need to put that in there. So AC squared can stay there. Now we just need to expand all of these. That's going to give me x squared plus 2x plus 1. If you need to, do yourself a little grid for each one. Take your time on it. It's worth getting right because it's one thing where once you know you're into a process, that's where you can definitely pick your marks up. So what's that going to give us? That's giving us positive x squared, take 4x with those two, and plus 4. And then we're going to have to expand this and double it. So let's draw another one for that. So x plus 1, 2, take x. That's giving me 2x, negative x squared, plus 2, minus x. So let's not try and do everything too quickly. Let's keep the 2 there, put a bracket in and put all this stuff into a single bracket. I've got negative x squared. I've got 2 take 1 is 1x. And I've got plus 2. And cos 120, I've just done negative a half. So let's write times minus a half there. And then start clearing this up. AC squared is going to equal, we've got 2x squared there, 2 take 4 is negative 2x, I'm being very slow and deliberate about what I do, 1 plus 4 is 5, and then over here we're going to have minus 2 still, oh no, I suppose we should, yeah, negative 2 times negative x squared will be plus 2x squared, negative 2 times that will be minus 2x, negative 2 times 2 will be negative 4, and I've just started putting a bracket in because I've just caught that out of my eye. I'm going to times everything by negative a half, aren't I? So that's going to change it all again. Well, don't worry about it taking a bit of time, just make sure we put it all in here. So if I times 2 by negative a half, I get minus 1, so that'll be minus x squared. If I times negative 2, well, that'll be plus 1 x, and this will be plus 2. You can always use your calculator if you get a bit befuddled at that point. Easy to happen when you're under pressure as well. Now, 2x squared take x squared is x squared. Negative 2 plus 1 is negative x. 5 plus 2 is 7. And that is what they had there. It's quite a lot of work, but there's 4 marks. It's not that much. And you probably could have snuck out a little stage or 2 in there if you'd wanted to. Right, so that's that bit. Now, finding the minimum value, the value of x for which AC has a minimum value. Well, what's going on here is AC is going to, although the square root will give you a positive and a negative, a length is only ever going to be positive. So if you look at this, that's a quadratic, isn't it? It's a positive quadratic, which means it's going to do something like that. So when that's at the minimum value there, that's going to give us the smallest value possible to find the square root of, which will then give us the smallest possible length. So we want the minimum of x squared minus x plus 7, which means we need to do completing the square on that. So for part B, x squared minus x plus 7, and I'm looking at that bit first to say, right, that's 1, isn't it? So minus a half squared, take, we're going to have to square a half and then add 7. So what does that give me? X minus a half squared, take a quarter, plus 7 would be plus 6 and 3/4. But that bit's not essential. We just need the minimum value of x. So we want the value of x for which it's minimum will be 6 3/4 will be the smallest value, and that's because this could be worth 0. It'll be worth 0 when the bracket is 0, and the bracket is 0 when x is a half. So therefore we can say x is equal to a half. Right, so here's a modelling log question, which these do take a little bit of getting used to, but the first bit, the equation of the line, isn't really too tricky. Just remember, if you're thinking y equals mx plus c, then y has just changed its name to log 10p. And what's that going to be equal to? Well, the log 10p intercept is 2, and then you're going to need to multiply t by the gradient of this line, aren't you? So I've put that in as a constant that could be written the other way round. So I'm going up. Well, what is the gradient of this line? Well, it's the vertical change, which is 2.2 take 2, over the horizontal change, which is 20 take 0. So what is that? 0.2 divided by 20. 0.2 divided by 20 is 0.01. So it's 0.01t. And if you've written 0.01t plus 2, then that's absolutely fine. Now, the value of a. Now this is the little clever bit here, where you're thinking that to the power of t, at the beginning, what is the time? The time is 0. And a times whatever b is to the power of 0 will just be a, won't it? Because b will be 1. So a is going to be represented by this 2 at the beginning. I say represented because what we're talking about is we can say that log 10p equals, and we know it equals a then, but also it equals 2 then, doesn't it? So if a is equal, then what is p at that point? Because it's log 10 of p when it's that is equal to a. So 10 squared is 100. So a is 100. And what is this value in context of the model? Well, at time 0, it is the population. So it's the initial population at the beginning of this whole thing when they started recording it. Finding b. Now, this is something that you may have forgotten about logging. If you plot log against t as time, then the gradient is here. It's different if it's a log plotted against a log, but don't worry. So if it's a log plotted against a log, then you just get your normal gradient there. But when it's a log against a t, the gradient is going to be log b. So log 10 of b is going to equal the gradient. Well, we know that the gradient is 0.01. So what's this saying? B is equal to 10 to the power 0.01. So whack that into your calculator and you should get 1.0 1.023. So there's a load more decimal points, but that's to 3 decimal places. So that is 1.023. So that's part C. And finally, finding the prediction predicted by the model. Well, the model is P equals AB to the power T. So P equals AB to the power T. Well, we now know that the population is 100 initially, so it's 100 times B is 1.023, and time, we're talking about 30 months later. So that's what you whack into the calculator. Do that and you get 197.8. So that is 197.8. So if we're going to predict how many, we could say 198. Now, actually, they'd accept anything between 197 and 200, because if you put the exact value of that in there, you'd get 199 point something that would round to 200. Right, binomial expansion. So the way I like to set this up is vertically. So the first term, we just need the first 3 terms. First term is going to be 2 to the power 6. The next term will be 6 choose 1, which is 6, times 2 to the power 5, multiplied by negative 3x, which is going to be a negative, isn't it? And then the third term will be 6 choose 2 times 2 to the power, drop the power 1, multiply the power of the next bit, up that one by 1. And then we just need to go through and work out what each of those are. So 2 to the power 6 is 64. 6 choose 1. Now just checking we know how to get that. Menu, oh no, not menu. Option, probability, there. 6 choose 1 times 2 to the power 5 times negative, oops, there, times negative 3. Oh, and I've put that in slightly wrong. So it was just that I'd put an X up there, hadn't I? So take that out, that gives us negative 576. And then if you put in the last bit, 6 choose 2 times 2 to the power 4 times negative 3, always put negatives in brackets when using it in the calculator, equals, gets us 2160. So our final answer here is going to be 2 minus 3x to the power 6 is equal to 64. Take 576x, add 2160 x squared. That should be there, that should be there. And then you should always put plus and dot dot dot, because we haven't done the whole expansion, have we? Just the first 3. Hence or otherwise find the first 3 terms in ascending powers of x of this expansion. Well, we take what we've done there and we multiply it by this bracket. So I've got the 1, I've got the x over 2. 1 times 64, all of this is going to be just the same as it was before. And then I need to do 64 times a half is 32, so that'll be 32x. Half of 576 is 288, so that's negative 288x squared. And I don't need these ones because they're x cubes. So then my final answer here is going to be 64. Negative 576 plus 32 is negative 544x, and then 2160 take 288 is plus 1872 x squared, and that's that. Okay, factorizing completely. The thing to notice here is how many square numbers we've got going on. First thing I can do is take a factor of x out of both. So I can say that that is 9 take 4x squared. Then we've got the difference between two squares, because 9's a square number, so is 4, so is x squared, and we're taking that from it. So that can then become 3 take square root of 4 being 2 x, and then exactly the same thing but with a positive, and that means that the x's would cancel out if you expanded that. So that is that completely factorized. By the way, you could have had 2x take 3 and 2x plus 3, because that would give you exactly the same thing as well. So that's okay. And then all we've got to do is sketch the curve of this equation. Well, we know that our roots are going to be at x equals 0. 2x minus 3 equals 0. Add the 3, divide it by 2. So we'll have 3 over 2. And here you'll have the negative of that as well. So we are going to have those points on our curve. 0, negative 3 over 2 and 3 over 2. Then you just need to think about the shape of what's going on, and if you're in any doubt at all, go to your graph. In fact, I would say even if you're not in doubt, things could go slightly wrong. So go to menu, hit 5, put 9x minus x cubed in there, hit draw, and you might need to mess around with the axes, but that looks just right for me there, and I can see that it's basically got that shape. So they want to see that shape, but the crucial bit is where it's meeting the x-axis, and you should be okay with that, but it does say show on your sketch the coordinates, so we should really have that 0, 0 and 3 over 2, 0 as well. The points A and B lying on C and having coordinates of -2 and 1 respectively, showing that the length of AB is that. Well, the first thing we need to know is where are those things? I'm not going to put it on that sketch that we had there before. So we were looking at y equals 9x take x cubed, and if x equals -2, we're going to have -18 take 2 is going to be -18 plus 8, which is -10. And so that's going to give us -2, -10. Now that seems wrong because I know that my curve was doing this, wasn't it? And that was at -1.5, so it's got to be positive. What have I done wrong here? What's my original? Oh, hang on, it's not x, it's minus 4x cubed, isn't it? So if I need to do 4 times that, so that would give me 8 times -18 plus 4 8's 32. That gives me, oh yeah, it gives me plus 14. That sounds better. -2, 14. And then if y equals 1, sorry, if x equals 1, I would have 9 take 4, which is 5. So that gives me the point 1, 5. So those are the 2 points I've got. So that is equals A, that is equals B. Now all I'm going to do is make a little sketch, and then we're going to be using a bit of Pythagoras. So I've got -2 and 14. I'll call this bit up here 14. So A is at -2, 14, and then B is at 1, 5, so that's going to be about there and there, 1, 5. So it's not a very to scale sketch or anything, but it doesn't matter. All I then need to think about is from -2 across to 1, that's 3. From 5 up to 14, that's 9. So AB is going to equal the square root of 9 squared plus 3 squared, which is the square root of 81 plus 9, which is the square root of 90. And you can put that in your calculator if you like, or that's root 9 root 10, so that equals 3 root 10, so K equals 3. Okay, so we've got a good old number E here. So we've got a formula n equals 1000, and that might not have come out too well. That actually should say minus k to the power negative kt. Write down the number of atoms when the substance started to decay. Well, this is a clever bit, because good old, when it started to decay is going to be 0 years. So anything times 0 is 0. Anything to the power 0 is 1. So 1 times anything is just what it is. So that means that the number of atoms must be 1000. Given it takes 14.4 years for half the substance to decay, find the value of K to 3 significant figures. So what have we got? We've got, it's going to be, n is going to equal 500 when 14.4 years. So you've got 1000 e to the negative 14.4 k is equal to 500. I could divide by 1000 and get that my e to the power negative 14.4 k is a half. And then what am I thinking? I'm thinking it's time to go to use the logs. So log e, we've got that special thing, haven't we, of calling that ln, because it's a natural logarithm. So what that means is e to the power of negative 14.4 k is going to be a half. So therefore, if I divide by negative 14.4, ln half over minus 14.4, that should equal k. So let's pop that into the calculator. ln 1 over 2, I could have put 0.5, negative 14.4 equals, and that's giving me 0.0481 to 3 significant figures. And then all we need to find out is how many atoms are left when t equals 30. Well, for that we go back to our original thing, and we're going to be putting in 1000 e to the negative 30 times 0.0481, which gives me 236.2. So 3 significant figures and a whole number, that's giving us 236.